Hello game makers, I'm David and this is the first episode in a mini-series where together I'll start little programming challenges and hopefully you'll be inspired to give it a try yourself and maybe take it further. I'm hoping on the screen you can see the finished product, and if you can, well that's a good thing and it means I managed to get something working. I'm recording this at the start so I don't know how it's going to go. For the first project I thought we could make a flocking simulator. A flocking simulator is a way of getting moving objects to cluster together in a really organic looking way. I've done it once before, so I'm already slightly cheating, but I remember you can get some really interesting emergent behaviour, great for birds in the background or spell particles. This might look like an intermediate level project, but actually I think together we'll be okay and it's simpler than it looks. Each episode will be a different coding exercise. There'll be a whole range of skill levels. Some projects might be smaller, some bigger, others not even be game related. In fact, most of the time they're not going to be game related. Also, it's not a guide on how to do this. It's definitely not going to be the best way to code this, whatever best even means, and it may not even be a good way of doing it, but it's about going on a journey together. The most important thing I want you to do is follow along and make your own better version. I don't want this to feel like a lecture, and I'm hoping at the end people of all skill levels will share their examples. So I want to encourage you, even if you just followed along with what I wrote verbatim, or if you're making your own flashier version, maybe you've used a similar thing in a previous game, share it with me on Twitter at davesinhispants and the Yo-Yo Game Twitter account, and always use the hashtag GameMakerPal, short for GameMaker Program Along. It'd be good to even upload this to the Opera GX platform so we can all have a play. I want this to be a learning experience for me as well, so do let me know if I've done anything wrong in the comments, or there's better ways of doing things. So, with all that said, let's have a look at what we want to make. I've pulled up the Wikipedia page for one type of flocking system called Boids. This works in both 2D and 3D. Today I'll be doing it in just 2D, but it's a good way that you can extend this project. What I like about this one is from 3 simple rules you get these complex behaviours manifesting. These 3 steps we want to follow are separation, alignment and cohesion. It does say it's already been used in some games like Half-Life, so maybe it's a tech you'll use in the future on one of your games. Let's look at each step and break it down. I'm not going to do them in the order shown, so let's look at alignment first. Here you can see the green Boid finds the other Boids around it. I'm going to call those its friends. It then tries to move towards the average angle that those friends have, so it's going to rotate to match their direction. Then in the cohesion step, we want to find the average position of all its friends and rotate to head towards that. Lastly, we need to make sure they don't get too close. This is called separation, so we want to avoid those ones near it. Great, well let's jump into actually making the project. So I'm going to start off with one of my default frameworks. It's got a few files in, help me get started. And as always, the hardest thing with a whole project is actually giving it a good project name. So while I'm deleting some of these initial files in this project, some of the observant among you may have realised that I've switched microphone. Through the power of editing, future Dave is going to narrate this because it just gives me a bit more control, talking about what I'm thinking and how things are working. So, let's start off with a basic object for flocking. So, these are going to be the actual things that move around. I'm also going to want a spawner. So, all this is just going to do is dump a whole bunch of these in our starting room. I'm now going to play around a bit with actually trying to get the zoom level right so you can actually see what I'm typing. Gets a bit crazy before it settles down, but we'll get there eventually. There we go. It's a bit of a nicer size. So, very start of the project, the very top, the very first thing that's going to happen is I just want 20 of these flocking objects to be around. I want them to start off at random positions, so I'm just going to say iRandom room width and iRandom room height. Don't care about the depth. And we'll put in our new flocking object. So let's get started with this flocking object. Let's give it an image first so we can actually see it. You're going to have to excuse all the drawing. I do them myself. This is the best art you're ever going to get out of me. So I'm just going to make it an arrow. We just want to know its direction. I think it will be fairly clear later on. So let's attach that sprite to the object and let's give it a run. Woohoo! There we go. We've got 20 arrows on the page. It's a good start. Right, let's get them to move. It's going to be fairly obvious now. They're all just going to slide to the side of the screen. Right, let's point them in different directions. So we're just going to give them a random angle to go at. And as you'd expect, there we go. They're all moving, but the arrow points in the wrong direction now. Let's fix that. So I'm going to create a step event now. If you're not familiar with GameMaker, the create event only runs once at the start when you create the object, and the step event runs every frame. Here we go. We've now got these arrows moving and pointing the direction that they should. So what I'm going to do now, I'm just have a bit of a think about how I want to structure this code. So the first thing, I want to know what other objects are near me. Yeah, and then I'm going to do the three other things. I want to match the direction of the people near me. I want to go to the middle point, the average position of those people near me. And also, I don't want to get too close to other ones. I don't want to bump into each other. There needs to be a bit of distance. Very sad, I know, but I want them to avoid being too close to their friends. Cool, so now I've got that sorted in my mind. What I'm going to do, I'm just going to break those down. Each is going to get its own region eventually. This just allows me to collapse the code, make things a bit more organised when I'm moving around. So I'm going to have two variables here. Friends and friends count. Now, later on, I will realise that I've called it friend count. So friends is just going to be an array, which is just going to list all of the friends that are near it. And the friend count is just going to be a number that says, you know, there's 5 of these near me. So I'm going to loop around every other flocking object, but I want to exclude this one. Now I'm going to find out how far away it is. So I want to create a list of all of the friends that are within this distance. So I'm going to call it friends dist. So if there's any other objects that are within 50 pixels of this one, I'm going to add them to this array. Woohoo, we found a friend. So we're going to add the instance ID of that object into the array. And then I'm just going to increase friend count by 1. That's what plus plus does, just adds 1 to the number. So let's actually test this. What I'm going to do is I'm going to create another image in that sprite. I'm going to make a white one. So there'll be a grey one and a white one. And if 2 of these flocking objects are near to each other, I'm going to make them white. Otherwise, it can stay grey. So let's give that a run. Here we go. So you can see those two were near each other. Let's get those ones about to crash. There we go. So they'll go white when they've got a friend. Otherwise, they'll stay grey. They're still just floating off. They're going off the screen. They don't change direction yet. And we're done that one. We're done the finding friends. Feel like we're almost there already. So now what we want to do is we want to match the direction of those friends. That was the kind of the first rule. So again, it's going to break it into a region just to make it easier to navigate later on. So, if this one has friends, I will notice in the future that one of them's called friend count and the other's called friends count. But if this flocking object has some friends, so all I want to do here is find the average angle of all of the voids that are near this one. So I'm going to keep a running total of the angle first and call that running angle, and then I'm just going to add the direction of all the other voids to this, and I just need to divide it by the number of voids or the number of friends this one had. So again, if you haven't seen them before, plus equals is just going to add the number on the right to the number on the left, and divide equals is just going to divide the number on the left by the number on the right. Here we go. I've noticed that typo I made. And I think I've realised that I want to call them friends count. So once we've found the average angle of all of the voids around this one, we want to match that angle. So quite simply, I'm just going to say the direction of this equals the new running angle. So there's a small bit of a jump cut there. There'll be plenty of other jump cuts. Image speed was still 1, so actually when I loaded, all these were flickering backwards and forwards like grey and white. So I fixed that now. However, you can see the problem is that they just instantly snap to the new angle, whereas that's not really what we want when we see like birds or fish moving around. There we go. So when they get close, they just all have the same angle. So let's fix that. So this bit that I'm just writing here, I end up using it quite a lot. So later on, I will move it into its own function. But for now, just to get things rolling, what we're going to do is going to say, if the angle is greater than the one it currently has, I want to add to it. If it's less than the angle it currently has, I just want to go towards that new angle. Here we go. So, I think I notice here that they're going away from each other. Now, give me a moment, but yeah, I've got the the plus and minus around the wrong way. So if we give that another try, there we go. So now they're just trying to match each other's angle. We can see they're already kind of grouping up. It doesn't look very organic yet, but we're getting there. So rather than just hard coding how quickly it can change direction, I'm going to have a new variable called angle change speed. So now I can really quickly in one place just change that, and it will change how quickly these voids are allowed to rotate. So next one along, done the first one. Next one, we want to go to the middle, the average position of where its friends are. This is going to be very, very similar to what we previously did. So while that was finding the direction they were going in, I want to find the average position and head towards that. So I could have put this in the previous block. It may have been a tiny bit more performant to do that. However, I was quite keen to structure it with these kind of like 3 rules that we were going to do. Oop, that was obviously meant to say group, not ground. So now I know the point in the world I want it to go to. We're working with angles here, so I want to turn that into an angle. So I'm going to do point direction to find out where it is in the world, or where I would need to face to go there. So it doesn't look like a huge amount has changed. They're still following each other, but at least I know the code hasn't crashed. So I'm quite content with that. Let's close that one. Now, let's work on the last of the rules. Oh yeah. First off, I'm just kind of listing things that I know I've got to do. They're just drifting off the screen. It's a bit hard to test when they're just like floating away from me. So let's get that sorted. Let's make sure that when they're off the screen, they just come back. How I'm going to do this? No surprise. I'm going to just say, if it is off the screen, then I want it to turn around and go back to the middle of the room. So again, I'm working with angles here. I'm just going to copy this over. Now, the new point direction isn't going to be the middle of the group it's with. It's going to be the middle of the room. I'm going to give this a play, and we'll notice that everything gets attracted to the middle of the room. Obviously done something wrong. Past Dave will notice it. I need to say if it's outside of the room. So now, any of these, when they leave the room, they'll start rotating back around, and they'll head to the middle. There we go. They're clumping up a bit too much. We now need to get them to kind of avoid each other and try and spread out. Quite often you'll see me try and change some of these variables, see if they're better variables, if it looks better. So I'm just testing here with a faster speed, watching them go out, making sure they come back correctly. So we've got them to clump up. We now need to get them to spread out a little bit. Now, up until now, the other Boyds near it I've been calling friends. Now, I don't know if the ones that are even closer should be their super friends. I decided to call them the enemies. So these are the Boyds that are too close. These ones are going to be called enemies, and we're just going to get it to move away from those. Again, we're going to have another variable here, just so later on we can have a play around, change these slightly, see what happens. So in the code that runs at the top, just the same way that we were finding friends, I'm going to find enemies. I could have done some nested ifs here. They didn't need to be kind of like separate. But later on, I think we'll have a bit of a play around with what happens if we make these circles different sizes. So what happens if you try and move away from enemies, but that has a bigger radius. But we'll get to that later. So I'm going to start off by just duplicating the rule that we had before. So I noticed when I copied it over, one of my comments was wrong. So that one was moved to the average position. And we're going to give this a run. So they're still clumping up. They're clumping up a bit more than they were before. It's kind of not what I was expecting. Later on, I will realise that because I copied and pasted the code, what it's actually doing is it's telling friends to be close, but enemies to be even closer, which is actually the opposite of what I wanted. So I'm going to put some debugging things in here, so I'm going to see what's happening. So again, if it's got more than 0 friends, if it has some friends, I'm going to make it white. If it's got some enemies, I'm going to make it go red. So I made a new image for that. Here we go. And this is when I realised that it should be friends count. I'm just going to replace all of those. When my fingers can find the keys, that is. Cool. That all looks good. Give that a run. Here we go. So when it's got a friend, it's gone white. If it's too clustered up, it's going to go red. what I'm doing here is I think the problem is that the two values are just overwriting each other. So what I do is I allow it to move, I allow it to rotate even faster when it's got an enemy. This is actually making it even worse, but we keep it like this, and you can see there's a bit of wobbling going on as well. So let's go and fix that wobbling. What I'm going to do is, when it rotates, I'm now going to make a function for this. So those 3 times when I tell it to rotate, or 4 times I guess, because I've got the if it's outside the room, I'm now just going to make a new function. This is what I want the new angle to be. And I've just realised that I'm also going to have to pass in the speed, because obviously there are ways that it can change speed differently now. Here we go. This is going to make my code quite a lot shorter and easier to read. I'm trying to work out why it's been given a red wiggly line, but I don't think it's anything that I've done. Cool, and I realise now that I didn't actually replace it for when it's off the screen, but oh well. So I'm going to speed it up a little bit. I'm also going to add more to the screen. There we go. I mean, they're definitely clumping together. Again, I still haven't realised that enemies never push away from each other. Here we go. Try and keep some distance. I've left the comment at the top there wrong, but now I've realised that actually it wants to go in the opposite direction from its enemies, so that'll help it move away from the enemies. Also here, to stop that kind of wiggling that was happening backwards and forwards, I'm just going to say that there has to be at least 3 degrees difference between where it wants to go and where it's currently going. And a tiny micro optimization here. Rather than doing angle difference twice, I'm just going to do it once, store it in a local variable, and use it for both if statements. Oh, and I'd never noticed, that should be -3. These are all things. I will put this project up on GitHub afterwards. I don't know if I'll get around to making these changes, but someone's more than welcome to do a pull request and make them for me. Cool, so things are starting to spread out a little bit better now. In my mind, it's kind of like acting a bit like a gas, where you can see that they're kind of forming these like these groups where they're kind of like equidistant, they're kind of like pushing away from each other, a bit like a kind of pressure wave. Let's add some debugging tools now. So I'm just going to make it so I can click to add more. copy the original code we've got, and I'm just going to get it to spawn on the mouse cursor. I love these like triangular shapes that they're making. Definitely like kind of birds when they're flying in the sky. Can spawn some more. Just make sure they're all coming back. And they're all kind of grouped together still. Brilliant. So that's kind of like the basics of what I wanted to get working. So now we can have a bit of a play with seeing what happens if we change some of these parameters. So what I'm going to do first is I'm going to allow them to have a random range of speeds and see how that impacts how they stay together. Have a think about what's going to happen if some of them move fast and some of them move slower. Do you think that some of them are going to migrate to one side of the screen? Do you think it's just going to be a big blobby mess? And I'll give that a run, and it is hard to see what's happening. Add some more in, so you can kind of see they still clump together. They're not as clumped up as they were. So just to make it visually more obvious which ones are moving faster and which ones are moving slower, I'm just going to draw a colour on top of them. So green ones will go faster and red ones I want to go slower. So there should be some fairly simple code here. However, I stumbled quite a bit trying to work out the HSV colour of it. So made them all red. That's absolutely correct. And then I just want to time this by their speed. However, the Dave that typed this originally hasn't realised that's now going to make it like 5 times 255. So I'm going to have to correct it. And I want to divide it by the maximum speed. Here we go. So you can see the... is it the green... No, red ones are moving faster at the moment. Green ones are moving slower. I do swap that round in just a bit. Also, remember that the lowest speed they can be at is 1. So I just I shuffle it all down, and here you can see the red one's going very slow. I know, green, medium, and then I guess blue is the fastest. Now, that code works. It's absolutely fine. I tried to improve it. I'm not going to make you sit through all that. So, fast forward of me spending far too long making silly mistakes. It's fine. And I just... I remember that I've got a map script that I wrote. And all this does is... it's a bit like lerp, but you can give it the output ranges as well. So I want to convert speed from a number between 1 and 5 into a number between 0 and 255. So now it's all working. And the interesting thing is you can see them clumping together by speeds. Seems obvious now, but you know, you get blocks of the purple ones together, the blue ones together. Because obviously if it's going faster, it's kind of outpacing and it leaves the group. If it's too slow, it's lagging behind and can't keep up with the group. So they kind of find groups of similar speed, which is fairly lovely. And you can see lots of these things, I don't let them play out for very long, but this one, the longer I leave it on for, the better the grouping is. By the end, kind of like there's very strong groups of like blue or green all hanging out with each other. So now, let's have a bit of play around with changing these distances. So first off, to help me debug it, if I'm hovering over one of the voids, I'm just going to draw a ring around it that shows us how far things need to be for it to be inside its like friend group. So here you can see, I think that's 50 pixels. That's the kind of grouping that we've been using so far. And 80 pixels it was, there we go. So what happens now if we make it huge? Oh. Let's have a look. So it's a bit more messy. It's harder to see groups forming. I'm going to add in a few more to see if that helps. I think that most of the time things are just in too many groups now. There's a bit of flowing around like water, but generally it's just one big cluster with a few like breakout groups now. So let's put in some debugging controls. Let's make it so I can change these live. I'm just going to put in some simple commands so that I can use the keyboard arrow keys to dynamically change its friend radius and enemy radius on the fly. Now let's just make sure I haven't done anything wrong, so I'm going to do some debug messages. So in the output you can see that it says 100, 100, 100, 100, loads and loads and loads. And as I change it, it is changing. 2 pixels per click isn't very good, and actually I'm really hammering at my keyboard here trying to increase the size, so we can just do that in code. Save me from smashing up my keyboard. So now, if I press up and down, it's going to change the friend distance. If I press left and right, it's going to change the enemy distance. Let's also display the enemy distance as well. So, keeping with our convention, we're going to make it red. And we're going to draw a red ring that shows all the enemy distances. Things are moving a bit too fast for me to keep my mouse over, so just to help me develop, let's move that down. As you can see, you can see the 2 sizes, and then when I press the keyboard keys, it starts making them bigger and smaller. So now, I start having to play around with what happens if I make these numbers very similar to each other. So the enemy radius is massive, and only a little bit smaller than the friend radius. Well, obviously things start to spread out more. It all becomes a bit less dense. Now also increasing the friend size as well, and as we saw before, they kind of all form into one big glob that stay together. Because the enemy distance is much bigger as well, they're a bit more dispersed. And kind of like they all reach the edge of the screen, and then kind of like some pressure wave, they try and like bounce each other back. It's very cool to see. Let's make it so they can't change angle direction as quickly. So one of the problems is that now it takes a lot longer when it goes off the screen to turn back around. So I need to add a whole bunch more. And you can see they're still kind of following each other. And it is kind of worth remembering here that, these interactions are very, very simple. All it knows is kind of like the local vicinity and what those ones are doing. But we're still getting these great emergent properties of them kind of like staying together and grouping as waves. We're getting kind of like, world-based movement even though it's like very local systems that are working. So I'm now going to give the friend distance. Each void is going to have a different friend distance. So think about what that's going to do. And a different enemy distance. Well, the problem is here, it is more lumpy. It's less hard to see them grouping together because they're not interacting as one anymore. They're kind of like, it's all a bit more sporadic as they move around. Let's remove it so they've all got the same distances that they're all using now. Let's make the speed much bigger, massive number. Well, maybe not that massive, that's too massive. So now they can move quite fast, and I can allow them to change direction quite fast. Very quickly you can see these kind of like, these chains of them forming together, swooping around up and down. I love that way the blue one comes down. Got one coming from the top there. So you're getting these big long trains of them forming together. Now, I might have added a few too many here. They've kind of all clumped together. All kind of like, they've started chasing each other's tail at this point. Give us a bit more room on the screen. I think it would have been quite interesting to see that. I don't think we ever properly see them grouping and chasing each other like that. But there we go. This would make a great screensaver. Love it. In my mind, I definitely see them like little groups of fish, kind of like following each other around. So a really important part of this to me is kind of like encouraging you to take this further. What are the next things you can do with this? Can we get trails going behind them? Maybe you want different types moving around. Maybe you have some that are chasing each other, some that are pursuing each other, some that are trying to avoid each other. Can you do terrain? Can you kind of like get an island or mountains, and kind of get them like birds or fish trying to navigate around these change? Look at the way they're kind of like swooping down the side there. There's maybe a lot of like code optimization that can be done as well. What happens? Can you get 100, 500 of these on a screen? What happens if you make them really small, moving very slowly, and you run it over a long period of time? What does that look like? Here you can see, it's hard to see because I don't hover over it, but I'm making the distance they're allowed to be at much greater. So they're all spread out now. I'm going to put it back to how it originally was. And this should now be what you originally saw on the very start of this demo. Here we go, lovely. So, like I said, there's loads of uses for this. I can imagine it being used in like bullet hell games. I can imagine it being used for like spells and particles. It might just be used for like little butterflies and stuff in your game that you want us in the background, just kind of like following each other very naturally, not very intensive. What's happening? So I think that's enough playing around, and I'd like to see what you do and where you take this. I'm going to put this project on GitHub, so there'll be a link to that in the description below. There's already a whole bunch of enhancements that you can just start with. That add better graphics, change graphics, make it look better. That's a really easy place to start. I'm sure there's a whole bunch of spelling mistakes that I made that can be corrected. I think some of my comments that I copied and pasted from other areas were never updated. Those were wrong. Please fix them for me. I've got to put the change directions script when the boys leave the room, so it's still just using the standard change angle code. When I was comparing the angle differences, I left one value as 3, and I think it should have been -3. Go and fix that for me. And I'm sure there's a whole bunch of other things that you saw, I made a mistake, that you can correct. Also, if you're making your own version, I want to see what you do and what changes you've made. Remember to share it with the hashtag GameMakerPal, which is short for GameMaker Program Along, and also include me, Dave's in his pants, and Yo-Yo Games Twitter account as well. If you already have this in one of your own projects, share the game. We want to see how it's been used. Thank you very much for watching. I'm Dave Strachan. I hope you enjoyed the rest of your day.